Hello, geometry students. Today we're going to look a little bit at circumference and arc length. So circumference, remember, is if we have a circle, it's basically perimeter for a circle. It's distance around the outside of the circle. And so it's just a length. It's not an area or anything. It's a length around the outside of the circle. So it's always measured in things like feet, centimeters, inches, nothing squared or cubed because it's just a length. Like basically if you cut open the circle and laid it flat and measured that, how long would it be? So circumference, the way we find this, and this should be reviewed, I'm sure you've heard this before, is pi times diameter. Or some people say 2 pi r. It's the exact same thing because basically this part, 2 times the radius, is the diameter. And so whether we say pi times diameter or 2 times pi times r, it's the exact same thing. Now because of this, I always like to bring this up because a lot of times when I say, what is pi? People will tell me 3.14 approximately, or something like that, or maybe a couple more decimals. But what is the definition of pi? Like, where does that number come from? And really, it comes straight from this formula. If you look at this c equals pi times diameter formula, if you just rearrange this and get pi by itself, so circumference is pi times diameter. If I want to get pi by itself here, since it's pi times d, I'd have to divide both sides by d. So in other words, that means pi is c over d. Or to say it another way, the definition of that number pi is the ratio of circumference to diameter in a circle. So that's just kind of a side note. We don't need to know that to find circumference and arc length. I just like to bring that up when we talk about this so that people understand, like, what is pi? Where does that number come from? It comes from basically take any circle of any size. If you find the length all the way around, divide it by the length of the diameter, that number is what you get every time, that 3.14 approximately. So let's see if we can find circumference of a circle here. So I've got a circle here. The radius of this circle is 9 inches. So if we're going to do pi times diameter, we've got to figure out the diameter. But remember, diameter is just double the radius if we go all the way across. So diameter on this would be 18. And so the circumference isn't really too bad to find. It's just pi times diameter, so the circumference of this would be 18 pi. Now, you could leave your answer like this. If something said to leave your answer in terms of pi, which is a big thing done on like the ACT and some standardized tests like that, that would be where you stop. But if you were doing this for some practical purpose and you needed to know the distance around this circle, you'd probably want it as a decimal instead. So as a decimal, this one comes out to about 54.55, or 56, sorry, 0.55 inches. So there is the circumference of that circle. All right, now a question that I'd like to ask to go along with this, because this is where we're going to start to get into the second part. Circumference, distance around the whole thing, that was review. What about arc length? Now remember, an arc, instead of looking at the whole circle, an arc is just a portion of the circle. So we're looking at just a part of the circle, and we want to know how long that would be if we laid it out flat. So what if we wanted half the circle? Well, if this is the entire circumference and we wanted half the circle, we would just cut that in half. And so I would do 1/2 times that 56.55 if we wanted decimal, or 1/2 times 18 pi if we want it in terms of pi. And so if I divide that by 2, I get like 28.27. All right, what if we wanted 90 degrees of the circle? Now this is a little harder because a full circle, we know from what we've done with arc measure already this year, is 360 degrees. So here's kind of what we have to think. What fraction of the circle are we using if we're using 90 degrees? Right, so think about that for a second. If the whole thing's 360 and we're using 90, what fraction of the circle are we using? So 90 out of 360 is the same as 1/4. And so basically we want 1/4 of the circle, or 1/5, or 1/4 of that 56.55. And so I'm going to do that. I'm going to do 1/4 of that answer. And that comes out to about 14.14 approximately. that's if we use a quarter of the circle, or in other words, 90 degrees of the circle. Now let's go with a slightly more complicated degree measure. So what if I used 167 degrees of the circle? Well, now we're not using half, we're not using a quarter. Half would be 180 degrees, a quarter would be 90 degrees. It's somewhere between those two, but it's not a nice fraction. However, you can always make a fraction out of this degree measure because this degree measure is always out of the entire circle. And so the entire circle is 360 degrees. So if I wanted to use 167 degrees, then the fraction of the circle I want to use is 167 360ths. I told you it wasn't a nice fraction, but that's okay. It doesn't really need to be a nice fraction. And so we want to use 167 360th of the entire circumference, or of the circle. Now remember, as far as like math goes, when you hear the word of means multiply. And so we want this fraction of the circumference, or of the whole circle, and so we want that fraction times 56.55. And so there's a couple different ways you could type this in a calculator. If you have the ABC button, you could use that on your calculator. You could just do 167 divided by 360, and then take that decimal times the 56.55. That would work as well. And so if I do that, this is about 26.23 inches. And all these are inches. I'm going to go ahead and put the units on there. All right, so that's how we find the length of a portion of the circle. And so let's see if we can generalize a rule for what we just did here. I'm going to come over here and draw a little bit more. And let's say this is the arc we're after. And just to give it a name, I'm going to call it AB. Now, a couple of things that we need to remember. When we measure an arc, there's an answer in degrees. When we find arc length, there's an answer in inches, feet, things like that. So there's a difference between arc length and measure of an arc. Measure of an arc is always degrees. Length of an arc is units, like feet, inches, miles, if it were a really huge arc. So if I have this angle in here, that's the same as the measure of the arc. So here's what we're going to do. Think about what we did. This angle is how much of the circle we're using. Now, whether I put that angle here or whether I put that angle here, it's the same thing. The measure of a central angle is the same as the measure of the arc it cuts off. So whether it's here or out here, the degree measure, it's the exact same angle. So here's what we're going to do. We're going to find the measure of the arc, not the length of the arc. This is going to be a degree measure out of the whole circle. Whole circle is 360 degrees, and we're going to multiply that by the circumference. And that's exactly what we just did in that problem above. That'll give us the arc length. And some people like to use the variable s for arc length. You can do that if you want, but I'm just going to call it arc length. So there's a general formula for how you could find this. Now, I know some people are really big fans of proportions, and so if you're a really big fan of proportions, you could do this. This comes out to the exact same thing, and you guys can mess around with some cross multiplying and see why this comes out to the exact same thing if you want to. But you could also solve this proportion if you would like. The measure of the arc out of 360 equals the arc length over the entire circumference. Now this kind of makes sense if you logically reason through what's going on in this proportion, because we've got the piece of the circle we're using out of the whole circle, the piece of the circumference we're using out of the whole circumference. And so these ratios would be the same, and so that proportion would also be a good approach. You don't have to do it both ways. Basically, this is like one option, this is a second option. Pick whatever makes the most sense to you to do this. All right, so let's see if we can put this to use on an example now. So let's see if we can find the length of an arc if we know this information. So we're going to try to find the length of arc AB in here. And so remember, if there's two letters on an arc, that means it's a minor arc. It means we're going the short way around, because technically this arc starts at A and ends at B as well, but if we were doing a major arc, we would use 3 letters instead of 2. All right, so we're doing this arc right here. Find the length of arc AB. We know the radius is 8 inches. We know the measure of arc AB, not the length. The measure is 97 degrees. So we're going to see if we can find, first off, the whole circumference of this circle. So circumference is pi times diameter, or 2 pi r. If the radius is 8, the diameter is the whole way across, so that's 16. So the circumference is 16 pi in this. Or if you like it as a decimal, let's figure out what that is. 16 pi is about 50.27. All right, so let's see if we can figure out the length. That, remember, the 50.27 is the length all the way around. Let's see if we can find the length just from there to there. So we're going to do something like this. We want a fraction of that. Now, let's think about what fraction we want of that. We're using 97 degrees. The full circle is 360 degrees. So we want 97 360ths of the full circle, or 97 360ths of the circumference. And so I'm going to do 97 360ths of that 50.27. All right, so let's do 97 divided by 360 and multiply that by that 50.27 to see what we get. And so the length of that arc right there is about 13.54 inches. All right, so there's kind of the general way to do this. And if you don't like this, if you'd rather do the proportion on this one would have looked like 97 over 360 equals x over 50.27, and then cross multiply and solve that thing. If you like that approach better, that would also work here. So there's how we find the length of an arc if we know the radius and we know how much of the circle we're using in degrees. If we knew a fraction of it, we would just take that fraction of the circumference. If we know how much of the circle we're using in degrees, we basically make it a fraction, because it's always out of 360 for the whole circle. So we take that fraction, or that degree measure, out of 360 to make it a fraction, and take that fraction of, or in other words, multiply by the circumference.